Good morning, students. We'll be starting with the B07, which includes 3 chapters: breathing and exchange of gases, body fluids and circulation, excretory production and their elimination. I'll be touching important aspects of these 3 chapters only, and memory oriented aspects I may not be able to tell about that. So without any delay, let us start the first chapter, breathing and exchange of gases. See here, we will study with the respiratory tree. Respiratory tree is called as. Respiratory tree starts with the nostril and it extends from the nostril into the nasal chamber, where a nasal chamber has hair, and it contains the mucosa layer which will trap the dust particles and pathogens, and it also humidifies the air, and not only humidifies the air, it brings the air to the body temperature. Hope you understood regarding the nasal chamber. Then comes larynx. It's made up of cartilage. 9 cartilage it's made up of. Larynx, which is also called as voice box, you know it. And after that, this is the nasopharynx, which is the one part of the pharynx, nasopharynx. Then comes the trachea. See here, nostril, nasal chamber, larynx, nasopharynx, trachea. These all are called as upper respiratory tract. That means you can understand these are the parts affected by common cold, upper respiratory tract. Coming down here, this is the left, see, trachea gets branched, right? Trachea gets branched at where? At 5th thoracic vertebrae. At 5th thoracic vertebrae, trachea gets branched into left primary bronchi and right primary bronchi. So bronchi, the bronchi will become secondary bronchi, tertiary bronchi. The tertiary bronchi will become bronchiole. Which bronchiole? Primary bronchiole, secondary bronchiole, tertiary bronchiole. And tertiary bronchiole will ultimately end with the alveolar duct. Alveolar duct, and it ends with the alveoli. Let me quickly tell once again: nostril, nasal chamber, larynx, nasopharynx, trachea, bronchi, 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 bronchiole, 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 and alveolar duct, and finally alveoli. Some important aspects to discuss are like this. See, students, from the nostril till the tertiary bronchi, from the nostril till tertiary bronchi, it's called conducting part. Function of conducting part to bring the air to the alveoli and to trap the dust particle as well as pathogen, humidifies the air and brings to the normal body temperature. So conducting part is from nostril till tertiary bronchiole, sorry. And after the air reaches to tertiary bronchiole, the next part is called as exchange part. An exchange part consists of alveolar duct and alveoli. Please remember, alveolar duct and alveoli is the exchange part. Nostril to bronchiole is the conducting part. One more point here. What is that? Whatever after trachea, means bronchi till the alveoli, is called as lungs. Hope the matter clear. And lungs is a lower respiratory tract which is affected by pneumonia. Hope you understood regarding the respiratory tree, and after discussing respiratory tree, we will be moving on now, students. See the things carefully. See, if I take see here, students, once. Yeah. I have taken some sticks here, sticks of Cocos nucifera. What's Cocos nucifera? Coconut, to explain something to you, and quickly. See this carefully. what I want to explain is, it is a airtight chamber now. It's an airtight chamber. In this part, whatever you see is an anterior portion. Which portion? Anterior portion. And whatever you see here is a posterior portion. Anterior, posterior portion. And whatever you see here is the dorsal portion. And whatever you see here is the ventral portion. Once again, anterior, posterior, dorsal and ventral portion. Okay. The dorsal portion, the dorsal part is made up of vertebral column. Vertebral column. And the posterior portion is made up of, tell me what? Diaphragm. Diaphragm. Clear? And ventral portion is made up of ribs. And lateral, not ventral portion is made up of sternum. And lateral portion made up of ribs. Once again, chamber called as thoracic, chamber called as thoracic cavity. That means called diaphragm can contract. Dorsal, that means if I do like this, so diaphragm has contracted and ribs has come front, that means thoracic chamber volume has increased. So who is contributing to increase in thoracic chamber volume? It is the, tell me what? The muscles of the ribs, and it is the muscles of the diaphragm. And diaphragm muscles are called as phrenic muscles. Phrenic muscles. Hope the matter very clear for you students. Now the thoracic chamber cavity is less now, but when you contract the diaphragm and ribs are contracting, then thoracic chamber cavity increases. By chance, if there is any puncture in the case of thoracic cavity, the person will end his life because thoracic volume gets changed and ultimately lungs volume also will get changed. Hope the matter is very clear for you. I want to tell one more thing to you students. This is the alveoli like this. Nearly 7 million alveoli are present. This alveoli has an alveolar sac. Clear? And this alveoli is surrounded by some cells here. We call it as a squamous epithelial cells of one cell thickness. Epithelial cells are one cell thickness except compound epithelial cells. That means it is a simple epithelial cells. So alveolar sac surrounded by simple squamous epithelial cells. Remember, after 23rd week, I'm telling regarding the very near to the 6 months or a second trimester I'm discussing regarding after 33 weeks. In the case of the fetus, alveoli, a chemical will be secreted, and that chemical is called as lecithin. And this lecithin acts as surfactant. It acts as a surfactant. Surfactant means it will not allow the walls of the alveoli to stick together. Because what happens after inhaling, when the person gets exhaling, the walls can stick. If the walls are sticking, then lungs get collapsed. Who prevent collapsing of the lungs is the lecithin, which is produced after 23 weeks of the gestation. That is the reason baby, if it is delivered in a 6 months, it cannot have independent life. After 7 months, it can have an independent life because lecithin is produced only after the 23rd week. Please remember that regarding lecithin. One factor we understood which prevents collapsing of the lungs is the lecithin produced by the alveolar wall. What are the remaining things? Let me explain that. See here. This is the lungs. If I take it, friends, lungs is covered by pleural membrane, right? Now, how many pleural membrane? Yes, it's a double pleural membrane which acts as shock absorber. The pleural membrane has the pleural fluid. The pleural fluid will always have negative pleural pressure. It has to always have negative pleural pressure than what? Than the pulmonary pressure. What's pulmonary pressure? Lungs pressure. That means always the pleural membrane will have, or pleural cavity will have negative pleural pressure, means less pleural pressure than the pulmonary pressure, which makes lungs to expand. So lungs are expanding because of the negative pleural pressure in the Tell me what? Pleural cavity. Let us quickly see this diagram. See students, I want you to concentrate here one thing. Second, there are so many diagrams in the textbook. How I have done an activity here, same thing you will be doing in your textbook, or else you can draw and do it, because diagram based questions will come like this. See here. This is a diagram which you have in a textbook. This is the epiglottis, which is a cartilage structure which prevents entry of the food into the windpipe called as trachea. This is a larynx called as voice box made up of cartilage. This is a trachea, also called the windpipe. Trachea has incomplete cartilaginous ring. Agree with me? It has incomplete cartilaginous rings, which is made up of hyaline cartilage, which prevents collapsing of the lungs. That means one more factor which prevents collapsing of the lungs is which one? One more factor which prevents collapsing of trachea. Trachea is the hyaline cartilage. Okay. After the trachea gets branched in the fifth thoracic vertebrae, then we have lungs portion. See here, lungs is made up of covered by pleural membrane, and pleural pressure should be always negative than the lungs pressure, and pleural membranes are present inside the ribs. Once it has appeared question. Alveoli has surfactant. After 23 weeks it is produced, and I told one more here, diaphragm will be dome shape when during expiration, means when the diaphragm is relaxed, and diaphragm becomes flat when person has to go for inspiration. Please remember that diaphragm contracts for inspiration, diaphragm gets relaxed for expiration. And diaphragm is made up of which muscles? Phrenic muscles. Please remember these aspects regarding the lungs. Like this, for each labels you will be writing their functions, because label and their functions can come. When you see two lungs, the lungs which is left side, the left lung is little smaller compared to right lung, because there is a heart located here. Yeah, with that we have finished regarding the structure of the lungs, and I'm moving for the next aspect called as mechanism of breathing quickly. See here friends, I told you this is anterior posterior portion. When a posterior portion is coming down, means when the diaphragm is contracting. Diaphragm contracts. Diaphragm contracts means the thoracic volume has increased. Intercostal muscles, which one? External intercostal muscles, where they are present? External intercostal muscles, if this is ribs, this is the intercostal muscles between the ribs. So the external intercostal muscles also gets contracted. So the external intercostal muscle contracts, diaphragm contracts, so thoracic volume increases. When thoracic volume increases, intrapulmonary pressure decreases. They are inversely proportional. So during that time, a active process occurs called as inspiration. Please remember, contraction, thoracic volume increases. That means relaxation of what? Intercostal muscles and diaphragm, where then the thoracic volume gets decreased, the pressure gets increased, leads to a passive process called as, yes, what is that? Expiration. Hope the matter is clear for you. This is regarding inspiration and expiration. Please see the picture here carefully. In this picture you can see carefully that, see, diaphragm has contracted, ribs has moved. See the arrow marks here, ribs are moving front. That means the chamber has becoming bigger, pressure is decreasing, air is entering. See the picture here, diaphragm is becoming dome shape, ribs are coming back. See the arrow marks here, chambers is decreasing, pressure is increasing, air is going outside. It was regarding, tell me what? Mechanism for breathing, which is also called as pulmonary ventilation. Hope the matter clear. You tell me how many times a normal person breathes? Yes, it is a 12 to 16 times a normal person breathes. I am moving to the next aspect, friends. I am going little faster because I want you to go through the textbook as I explain, and you can note down the points also. See here, I'm going for respiratory volumes and respiratory capacity. Respiratory volumes are calculated, means found out using a instrument called a spirometer. You know it, spirometer. See here. Respiratory volumes are different type. This is a very important area for a competitive exam. Tidal volume. What's tidal volume? A volume of the air a person can inspire or expire during normal respiration. Means normally when you do inspire and expiration, it is called tidal volume. How much it is? 500 ml. That means you are inspiring 500 ml, expiring also 500 ml. And this 500 ml, is it per minute? No, it's for per inspiration, per expiration. Now, how much per minute is a tidal volume? See here, 12 to 16 time a person breathes, right? So 500 into 12, 500 into 16. 6000 to 8000 ml is the tidal volume per minute. They may change the value of the number of breath. Then you have to calculate the tidal volume. That is the one question can come. Please remember 500 number. Going to inspiratory reserve volume. Just listen to me. A person is forcibly inspiring. When he is forcibly inspiring, he is going to inspire some air in addition to 500 ml called as tidal volume. That additional volume of the air a person can inspire during forcible inspiration is called as inspiratory reserve volume. Means you are going to add still more to 500. That is how much? 2500 to 3000 ml. I can tell you it is a half liter above tidal volume. It is 2.5 to 3 liters. In remembering the liter is easy. Inspiratory reserve volume is more compared to expiratory reserve volume. What is expiratory reserve volume? Volume of the air a person can expire during forcible expiration. He is forcible expiring, then 1000 to 1100 ml of the air goes outside. Is it including 500? No, it's excluding 500. Remember that. So IRV and ERV both are excluding 500 means tidal volume. What is reserve volume? Residual volume. It's called RV, right? What's the residual volume? Even if you forcibly expire, some amount of the air will remain in the lungs. That is called as residual volume. A volume of the air remains in the lung even after forcible expiration is called as residual volume. And residual volume is how much? 1100 to 1200 ml. Please remember, the volume of the air which we can inspire is more, forcible is more, and expire forcible is less. Continuation of 1100 is written here. See 1100 to 1200. You can relate these two so that you can remember easily. And the textbook residual volume is present in next page, and ERV is present in previous page. Like that also you can remember. These are all respiratory volumes, and respiratory volumes are used to calculate what? Tell me. Respiratory capacities. Quickly we'll go through that. Inspiratory capacity. What is inspiratory capacity? A volume of the air inspired after normal expiration. A person is inspiring. How much he is inspiring after normal expiration? That means person is made to breathe 10 times, and next expiration is going to be normal, then followed by inspiration. When he does, what is the amount of air he is inspiring? That is called inspiratory capacity. Formula is IRV plus TV. How much TV? 500. So what is the value? See here. IRV can be 2500 or 3000 as we told earlier. So 2500 plus 500 TV, 500, the value comes 3000 to 3500 ml. That means I can tell 3 liters to 3.5 liters. So please remember that 3 liters to 3.5 liters is the inspiratory capacity. Is already come to choose the wrong and right pair. Not already, repeatedly it's coming. Please learn this. Expiratory capacity, same. It's a volume of the air person can expire after normal inspiration is called as expiratory capacity. It is ERV plus TV. ERV can be 1000 or 1100 plus 500 plus 500. The range is for 1500 to 1600 ml. Please listen and note down that, or else you better you calculate also, so that you can remember it. So among ERV and IRV, which is more? Yes, IRV is more, because IRV is more, and so IC is also more. Going to the functional residual volume. What is functional residual volume and residual volume difference? A volume of the air present remains in the lungs after forcible expiration is residual volume, but volume of the air remains in the lungs after normal expiration is the functional residual capacity. That means functional residual capacity includes RV plus ERV. Why ERV? This ERV you would have lost if you are expiring forcibly, but since you did not lose it, you would add the ERV plus RV. So ERV plus RV is equal to FRC. Calculation when you do, I want you to calculate. The answer is 2100 to 2300. That means 2.1 to 2.3 liters, or 2100 to 2300 ml. Clear? See, one more way question can come. How to? They may give ERV, they may give FRC. ERV and FRC they may give. You have to calculate RV. Hope you understood. So RV is equal to FRC minus ERV. That also can be asked. Please remember that. We are moving on now, and I wanted to mention one point here: residual volume. That some amount of the air will remain in the collapsing of lungs. One is the lecithin, a surfactant. Second, negative pleural pressure. Third is the residual volume. Coming back to the vital capacity, we see the vital capacity can be calculated two ways. First of all, what is vital capacity? A volume of the air means a maximum volume of the air inspired forcibly after forcible expiration. Means expiration is also forcible, inspiration is also forcible. Both are forcible. Then it is called as vital capacity. Vital capacity is equal to IRV plus ERV plus TV. And what is IRV value? What is TV value? You already know it. I want you to calculate. When I calculate, the value comes 4000 to 4600 ml. You can remember in liters, 4 to 4.6 liters. Okay. Finally comes the total lung capacity. TLC it's called as. What is total lung capacity? See, a person is forcibly inspiring. Then 100% he is taking what? VC, vital capacity. And he already has some amount of the air in the lungs, right? That is called RV. So total lung capacity is VC plus RV, or else VC is equal to IRV plus ERV plus TV plus RV. It's very clear for you, students. This can be asked in different way. What is the RV formula? RV is equal to TLC minus VC, they can ask. What is VC is equal to TLC minus RV, they can ask. In different way this can be asked. Remember all this respiratory volume. You can take a snapshot if you want, or else I suggest you to calculate by yourself so that you can remember for long time. I'm moving on, students. After respiratory volumes, we are moving to the next aspect called as exchange of gases. See here. The exchange of gases is because of three factors. Partial pressure of gases is one factor. Solubility of gases. Solubility of the gases of the oxygen as well as carbon dioxide. Partial pressure of the gases we will be discussing later. Solubility of the gas, if I take, students, among oxygen and carbon dioxide, who is more soluble? Yes, carbon dioxide is soluble, so it requires hemoglobin. So who is more soluble? Carbon dioxide. And thickness of respiratory membrane, that I will discuss a little later after discussing exchange of gases with the help of picture. I want you to open the picture. See, in the textbook In the table they have given partial pressures of the oxygen and carbon dioxide, not in the diagram. You can note down that in the diagram itself so that it's helpful for to understand. So partial pressure of oxygen in the air is very high, 159 mmHg, and carbon dioxide is 0.3 mmHg. In atmosphere I am discussing. But when you compare that to the alveoli, 104 is regarding oxygen, 40 is regarding carbon dioxide. Please listen now. First exchange occurs between higher partial pressure to lower partial pressure. Means 159 and 104 you have to compare. 104 is for oxygen in the alveoli, 159 for atmospheric oxygen. So 159 and 104 is the first comparison. That means the air is coming from where to where, tell me? The air is coming from atmosphere to alveoli for 159 to 104. Similarly, when you compare the carbon dioxide, 0.3 in the atmosphere and how much in the case of the alveoli? 40. 40 to 0.3. That's the second comparison. That means the air is coming from 159 to 104 and 40 to 0.3. One comparison is already over regarding the exchange between atmosphere and alveoli. Let us go to next comparison. When you compare the alveoli and blood, you compare alveoli to the which blood? You have to compare first alveoli to deoxy blood. Alveoli to deoxy blood for exchange of carbon dioxide. Alveoli to oxy blood for exchange of what? Nothing. We have to compare alveoli and deoxy blood. Please see here. When you compare alveoli, 104 is alveoli oxygen. How much in the case of the blood, deoxy blood? It is just see here 104 and oxygen is how much? 40. That means when you compare 104 and 40, which is high? 104 is high. That means oxygen is coming from 104 to 40. That means oxygen is added from the alveoli to deoxy blood. So the deoxy blood partial pressure of oxygen becomes more. How much it becomes? It becomes 40 to 95. It has become 40 to 95 since you added oxygen. Hope the matter is clear. Similarly, for exchange of carbon dioxide, 45 to 40. 40 where? Alveoli. 45 where? Deoxy blood. So you are adding from 45 to 40. So I'll take it once again here, one example. 104 oxygen to, tell me what here? Tell me 40. 104 to 40 we took one for oxygen. One more we took what? Tell me now. 45 to 40. Right? It's for carbon dioxide. Tell me, what is the difference here? 104 and 40, lot of difference is there. But 45 and 40, if you see, difference is less. It is enough because carbon dioxide is more soluble. So the difference in a partial pressure, even if it is less, it is fine for a carbon dioxide exchange, but not for oxygen exchange. Please remember that. Coming to the another tissue level, third comparison. What is that? 95 mmHg is the oxygen blood, and tissue how much? Compare it here. See here. This is not there in textbook. It is there in table. You can write on here only. The comparison is for oxygen 95 to 40 is the first comparison, and 45 to 40 is the next comparison. That means for exchange of carbon dioxide between tissue and oxygen blood, between deoxy blood and alveoli, the numbers are same. What is that? 45 to 40, 45 to 40. Hope the matter is very clear. Please remember these values. I'll repeat once again. Always gases move from higher partial pressure to lower partial pressure. Comparisons are what? Atmosphere to alveoli is the first comparison. Alveoli to deoxy blood is the next comparison. And oxy blood to tissue is the third comparison. I want to make you to understand one point. See, what is the partial pressure of oxygen in the oxy blood? Tell me. 95 mmHg. Correct? 95 mmHg. Is there any oxygen in the deoxy blood also? Yes, it's a 40 mmHg. That means 95 mmHg. If I compare, one person called as oxy blood had 10 chocolates. Among 10 chocolates, it has given maybe 6 chocolate to tissues. What is chocolate? Oxygen. Still 40 chocolates are with whom? Deoxyl blood. That means deoxyl blood still retains some amount of oxygen. Reason? If by chance if a heart is not functioning properly, then still tissues will not die because there is some reserve volume of the oxygen present in the deoxyl blood. Please remember this aspect is already appeared. So one thing you understood, deoxyl blood also has oxygen. Second point you should remember that when a person go to high altitude like a Rotang Pass or a Manali, when he goes, where condition, agree with me, during that condition when a partial pressure decreases, what happens? See here. In that condition, if a deoxyl blood brings 10 chocolate, it will give 8 chocolate to tissue. Means it is giving more oxygen to tissue. That means more and more oxygen will be given to tissues in the hypoxic condition. Reason? Near to tissue, affinity of hemoglobin for oxygen will tissue so that it can give more oxygen to tissue because conditions are not suitable for the body. Hope you understood regarding exchange of gases. After that, exchange of gases, I'm just going for the exchange of gases which occurs between the blood and alveoli also. See here, this is a picture I taken of textbook only. It's alveoli. It's alveolar cavity, squamous epithelial tissue having one cell thickness. And this is the alveolar or squamous epithelial tissue resting on the basement substance. This is a blood vessel, and that is also having endothelial cells, which is also single cell thickness. Always remember, squamous epithelial cells are single cell thickness, which is also having basement substance. That means squamous epithelial tissue, a endothelial cells of the blood vessels, squamous epithelial tissues of alveoli, basement substance of the both, together three things: squamous epithelial tissue, basement substance, membrane. Hope the matter is very clear. The respiratory membrane is made up of 3 layers. And by chance if a mucus is the alveoli wall because of the thin and elastic in nature. But whereas a person is getting emphysema or person is getting silicosis or any other condition that may be asbestosis, what happens is, in that condition, this lining of the alveoli becomes more and more made up of fibroid tissue. As fibroid tissues goes on increasing, it becomes less elastic. As it becomes less elastic, exchange becomes difficult. That's what happens in the case of silicosis or even in the case of emphysema also. Means its wall gets damaged. Coming here, friends, see here, this is the blood vessel. That means it is getting oxygen from where? It's getting oxygen from the heart by the right ventricles and by the pulmonary artery and bringing deoxy blood, and it is the RBC which will receive the oxygen and give out the carbon dioxide. And so the blood becomes what blood? Tell me. Oxy blood it becomes, and taken by pulmonary vein to the left atria. Please remember all this thing regarding the exchange of gases. After we finish regarding exchange of gases, we will move to the next aspect, students. The next aspect which we are going to study will be transport of gases. And transport of gases occurs where? The transport of gases occurs in the blood. And transport of gases means we are discussing 2 respiratory gases. First is oxygen, next carbon dioxide. Let me go for the oxygen first. I told you oxygen is less soluble. It's less soluble in the blood plasma. Since the oxygen is less soluble in blood plasma, majority of the oxygen, means 97% of oxygen is carried by hemoglobin in the form of oxyhemoglobin. Please remember that. And 3% will be carried by blood plasma. Hope the matter very clear for you. So blood plasma carries 3% and 97 by hemoglobin. Let us quickly look into the hemoglobin structure here. Hemoglobin is a adult hemoglobin. A adult hemoglobin has 2 alpha and 2 beta chains. You have studied in detail this in the sickle cell anemia also. All 2 alpha and 2 beta chains are there. So we tell 2 alpha 2 and beta 2 in adult hemoglobin. But if you see fetal hemoglobin, it has 2 alpha and 2 gamma. 2 alpha and 2 gamma. So fetal hemoglobin is called alpha 2 and gamma 2. Please remember that. So fetal hemoglobin is not exactly like adult hemoglobin. That means in adults, this gamma hemoglobins, gamma chains are replaced by beta chains. That's one aspect. And what is the reason for it? You'll understand it later. You should remember one thing, that in the hemoglobin, the core of this region, this is the core region. This core region is having the part called heme and surrounded by this region called as globin. The heme is the organic structure, organic molecule which contains iron here. In which form? In a ferrous form, Fe2 plus form. Please remember, and this ring which is surrounding the iron will be called as, tell me, yes, it's called as porphyrin ring. Porphyrin ring it is, which is surrounding the iron. Fe2 plus, you remember, and how many oxygen can be carried by a hemoglobin molecule? It's a 4 molecules. Hope the matter very clear for you. And very interesting one point I tell you, listen. 100 ml of the blood can carry around 20 ml of oxygen. But it delivers 5 ml of oxygen to tissues. Are you understanding? It carries 20 ml, but it delivers 5 ml of oxygen to tissue. That means 5 ml is delivery and 20 ml is a carry. Hope the matter is very clear. And in a hypoxic condition, this delivery amount will become more. Remember, in a severe hypoxic condition, it can even deliver up to 15 ml of oxygen to tissue. Please remember that. With that, we will be moving to the next aspect called as oxygen dissociation curve. And this is the most important and several times appeared question. I'll be concentrating more regarding that now. Listen carefully regarding oxygen dissociation curve. See here, a oxygen dissociation curve involves in x-axis partial pressure of oxygen in a mmHg from 20 to 100 I have written here, and in a y-axis is a saturation of hemoglobin with the oxygen. It's a percentage saturation of hemoglobin with the oxygen. Hope all of you have textbook with you. As I'm explaining, please go to the textbooks and you keep the textbook with you only. Okay, see here now. What happens? When you draw this plot, it gives sigmoid curve. Sigmoid curve. That means initially increases, and it becomes saturated. It gets saturated at which point? At 97%. That means 97% of oxygen is carried by hemoglobin, as we mentioned earlier. Now listen to the next word now. What is that? If this graph becomes bent down, maybe like this, the graph becomes bent down like this. Are you understanding? That means it is called as shifting towards what side? Right side. You understand this way. See, you're keeping a textbook here like this. This right hand, left hand, right side, left side. Similarly, okay. So it is shifting towards right side if it is coming down, shifting towards left side if it is going above. And what is the meaning? Just see here. If it is shifting towards the left side, means it's an association of oxygen with the hemoglobin. And it occurs where? In alveoli. In alveoli, oxygen binds to hemoglobin, and that is called as shifting towards what side? Left side. And this to occur, there's a requirements are there. What is the requirement? Just see here. For association to occur, partial pressure of oxygen to be more. That's the way of remembering. Only oxygen is more. It's a common sense that oxygen will be more in the alveoli region. Rest all will be less. But with that, you can derive an understanding that when H plus ions are less, pH will be more. That you remember. So this is a condition required for association to occur, and that is the reason, since association occur when hemoglobin binds with the oxygen, that will be called as Haldane effect. Haldane effect. Please remember which of the following condition is required for Haldane effect. That question can come. Moving now. When a graph is shifting towards right side, shift towards right side means it's a dissociation of oxygen from hemoglobin. It occurs in tissue level. Occurs in what level? Tissue level. Their conditions are what? You just tell me. If a hemoglobin has to lose the oxygen, its affinity has to decrease, right? For that, partial pressure of oxygen should be less. Rest all are more. See, CO2 should be more. Temperature should be more. H plus ion more. So these all are more. And this is less. Please remember that. And pH, since H plus ion is more, pH will be less. Less means acidic. Here pH will be basic. Hope the matter very clear. And this shifting towards right side means dissociation is called as Bohr's effect. How to remember? See here. Bohr starts with a B. B means below. The graph is coming below. H means height. Height means the graph is moving above. So remember, if it is moving above, it's a Haldane effect. If it's moving below, it's a Bohr. Shift towards the right side. Left means association, right means dissociation. Conditions for association, conditions for dissociation. Hope the matter very clear. Moving on, see here. If I take a same graph of oxygen dissociation curve, ODC, of the adult and fetus, fetus hemoglobin has more affinity for oxygen than the adult. That is the reason shift will be more in the case of fetus towards left side and adult will be less. So this is the ODC, oxygen dissociation curve of the fetus and adult. Please remember, who has more affinity for oxygen? It's a fetus. Sorry, affinity for. So hemoglobin has more affinity for oxygen in the case of fetus because it's a alpha and gamma chains. Clear? With that, we are moving to the transport of the carbon dioxide quickly. See here. Carbon dioxide is transported in three ways. 70% in the form of bicarbonate, 20 to 25% in the form of carbaminohemoglobin through the RBC, and 7% from the blood plasma. So highest is bicarbonate, next comes carbaminohemoglobin, next comes 7%. If a hemoglobin has to bind with the carbon dioxide, then for that partial pressure of carbon dioxide should be more, right? And partial pressure of the oxygen should be less. Please remember that. Because this is happening in where, you tell me? Happening in the tissue. In tissue, partial pressure of oxygen will be always more. Quickly we will go for this one because this is a very important one with the help of diagram. This diagram is not there in the textbook, but this diagram is required only for understanding because this diagram will not come in competitive exam. But for understanding this diagram is very important. See the conditions carefully. These are the tissues. Which tissue? Body tissues. And the tissues are always surrounded by interstitial fluid. It's an interstitial fluid which is also called tissue fluid, which later becomes lymph. Once again, whatever I have drawn with the fluorescent color here between the cells, it's an interstitial fluid which will later become cellular respiration, and they will release what? Carbon dioxide. They release carbon dioxide. And this carbon dioxide will enter the red blood cell, RBC. So carbon dioxide enter the red blood cell. That means where, you tell me? This is occurring in where? Tell me. In a tissues, body tissues. After carbon dioxide enters to the RBC, it will react with the water to pick up carbonic acid. H2CO3 means carbonic acid. And this is done by which enzyme? Fastest enzyme in the world. whose name is carbonic anhydrase. So carbonic anhydrase makes reaction of the CO2 plus H2O to become H2CO3. And you already know that it's a fastest enzyme, product will be very high. H2CO3 will dissociate into HCO3 minus and H plus. H plus means, that means pH is becoming acidic. Please remember that. And as the pH becomes acidic here, one more thing you should remember. HCO3 goes outside of the RBC. Chloride comes inside here. It's an antiport. HCO3 goes outside. Chloride comes inside. This phenomenon occurring in a tissue where chloride ion concentration increases inside the RBC is called as Haldane effect. Sorry, not Haldane effect. It's called as, I'll write here, it's called as Hamburger's phenomenon. And Hamburger's phenomenon is also called as chloride shift. Chloride shift. Hope the matter is clear. The increase in the concentration of chloride ion in the RBC near to tissue is called as chloride shift or Hamburger's phenomenon, which is occurring in a tissue region. Okay. After that, this HCO3 has present in where now? Blood. It circulates in blood. Circulates from blood from where? In tissue, and comes to heart, and from the heart it reaches to lungs now. As it reaches to lungs, in lungs you already know that partial pressure of oxygen is more and partial pressure of carbon dioxide is less. In this condition what happens? HCO3 enters the RBC back. It enters the RBC back, reacts to the H plus, forms H2CO3 means bicarbonate, and bicarbonate will carbonic acid, and carbonic acid will dissociate into H2O and CO2. And this CO2 which is formed in the alveoli region will be given to alveoli and it goes out of the body. So is the reaction is reversible here? Yes. This is the region where what occurs, you tell me? This is the region where Haldane effect occurs, where in the alveoli region. This is the region where what occurs? Bohr's effect occurs, in where? Tissue region. And chloride shift is called as what phenomenon? Hamburger's phenomenon. You can take a snapshot of it, friends, if you want. And it's a very important aspect of where we discussed all the phenomenon called Bohr's effect, which is occurring tissue level, Haldane effect occurring in alveoli level, and chloride shift called as Hamburger's phenomenon. And if I ask, sir, as the HCO3 got inside, is the chloride is going outside? Yes, chloride is going outside here. It's an antiport. Hope you have took a snapshot of it, and I'm moving on to the next aspect, and it's a very important aspect. Always students will be having confusion regarding that, and that will be regulation of respiration. See here, this is the heart and this is the aorta. You know, aorta is the largest artery which carry what blood? Oxy blood. Agree? Okay. But do you feel carbon dioxide is also there? Yes, because oxy blood also has carbon dioxide. See the concept here. Aorta has one artery called as carotid artery. And this carotid artery supplies blood to the head region. See here, this is the carotid artery and this is aorta. All of you see the point here. This aorta and carotid artery has something which are written in a dot dot dot. Can you see here? And these are called as chemoreceptors. Chemoreceptors. And these are chemoreceptors of what? These are chemoreceptors of H plus and chemoreceptors of carbon dioxide. That means we don't have any receptor for oxygen. We have a receptor for H plus as well as carbon dioxide. Please remember. So chemoreceptors will receive the information that what is the concentration of H plus and CO2 in the blood. Which blood I am discussing regarding? Oxy blood. See here now. That is again chemoreceptors were present in a carotid artery as well as aorta. This is a brain region. In a brain region, two important parts regarding respiration. You should remember, one is a pons region. It's also called pons varoli. Second is a medulla region. Pons and medulla region. Concentrate very well. Pons region has pneumotaxic center. Pneumotaxic center. Medulla region has respiratory rhythmic center. Hope you understood. Pons region has pneumotaxic center. Medulla region has a respiratory rhythmic center. Now see here. In the medulla region, red color I have drawn here, there are there's a chemosensors. Chemosensitive area it's called as. Chemosensors of what? H plus and CO2. That means if this gives information that is received by chemosensitive area. Hope the matter very clear. Let me start the explanation now. What is that? When we close our nostril, means you are not inhaling or exhaling. The body is undergoing respiration. In the oxy blood, the concentration of carbon dioxide and H plus may be increasing now. So increase in the H plus and CO2, if when it's increasing, the chemoreceptors will send the information with the help of neurons to the chemosensitive area of the medulla region. They got the information, chemosensitive area has got the information that H plus and CO2 has increased. Now, that information will be sent to the pneumotaxic center because it's like a boss. Pneumotaxic center understood that, oh, the H plus and CO2 has increased. The pneumotaxic center will guide the respiratory rhythmic center and it tells that, see, now it is time for increasing the expiration, and so that you can remove the carbon dioxide and you can decrease little inspiration. So pneumotaxic center, see here, pneumotaxic center increases the expiration and decreases the duration of inspiration. Is the matter clear? That means when you're closing a nostril, you feel urge for expiration. That is because of increase in the carbon dioxide concentration or decrease in oxygen concentration. Remember, it's because of increase in carbon dioxide concentration because we don't have any receptors for oxygen. Hope you understood regarding this aspect. I'll just keep it like this. You can take a snapshot of it. Pons has pneumotaxic center, medulla has respiratory rhythmic center, and chemosensitive area in the respiratory rhythmic center means in the medulla region, and chemoreceptors in the case of what region? Yes, carotid artery and aorta. Please remember this aspect. Who is decreasing the rate of inspiration and increasing rate of expiration? It's a pneumotaxic center, and it is controlling respiratory rhythmic center. Hope you note down that. Note it down, and I'm moving on to the next one, last aspect called disorders. See here. Disorders, when you're discussing, first is the asthma. Asthma, a condition where difficulty in breathing lead to wheezing, a kind of sound, and because of bronchi and bronchial gets inflamed. Reason for inflammation is the mast cell which is producing histamine. When a mast cell forms histamine, what happens? Bronchi and bronchial gets inflamed. After the asthma, we are discussing next called as emphysema. Most appeared question it is. Emphysema, most appeared question, several times appeared question. In emphysema, respiratory surface gets damaged. Whenever the word comes respiratory surface gets damaged, it's emphysema. Whenever the word bronchi and bronchial gets inflamed, it's asthma. Please remember that. See here, in the case of emphysema, which is preferably by smoking, the wall becomes less elastic, more fibrous tissue will be there, exchange of gases becomes difficult. Moving to occupational respiratory diseases, means the place where they work, because of that they get diseases. This is a appeared question several times. Asbestosis, since they are working in asbestos company. Silicosis, pneumoconiasis, asbestosis, silicosis, pneumoconiasis or pneumonia, pneumoconiasis or black lung disease, since they are working in a coal industry. These are all respiratory disorders because of occupation. Hope the matter clear. Last one discussing dyspnea, painful breathing. The painful breathing is called as what? Yes, it's called as dyspnea. Hope you understood, friends. With that, I'm telling the end for this chapter and moving to the next chapter, friends, that is the body fluid and circulation. In the body fluid and circulation, when I discuss body fluid and circulation, the body fluids are two. Tell me what is that? One will be blood and second will be lymph. And lymph is also called as what fluid? Tissue fluid. And lymph is flowing in what? Lymphatic vessels. Lymphatic vessels. Hope the matter is clear. Lymph do not have RBC. Do not have RBC. Which one? Lymph. Lymph has WBC. Lymph has rich in fat. Please remember, lymph is rich in fat. It has do not have RBC. Lymph has less platelets. Please remember regarding lymph, it do not have RBC. That means color will not be red color. Then blood, if I take students, I will not be discussing more about blood. It's a memory oriented aspect. I want you to note down that regarding the blood, all the aspects like all these structures you remember regarding that, granulocytes, all these aspects. Blood, when important question can come under the blood is when a plasma, from that if you remove fibrinogen is responsible for clotting, then the product is called serum. So serum is equal to plasma minus fibrinogen. Please remember, this aspect can come for competitive exam. And how many type of proteins are present in the blood? 3 types. One is fibrinogen, and second is albumin, and third will be globulins. And please tell me which is responsible for fighting against pathogen? Globulins. Albumins for blood colloidal osmotic pressure, BCOP, and fibrinogen responsible for clotting of the blood. 3 proteins are there, and that's over. Now, if I ask you regarding the blood has RBC, red blood corpuscles, RBC has 12 to 16 grams of the HB, hemoglobin, you know it. RBC is formed in red bone marrow. All the blood cells are formed in a red bone marrow. As age progresses, bone marrow becomes yellow. Then the production of the erythropoiesis capacity decreases. And erythropoietin is a hormone responsible for RBC production. That is the reason what happens in the case of kidney damage. If a kidney gets damaged, erythropoietin concentration decreases, then the person will have a difficulty regarding production of RBC also. Graveyard of RBC is what? Tell me. Spleen is a graveyard of RBC, and RBC number will be very high, and RBC is affected by a disease called malaria, that also you know it. And RBC can carry respiratory gases, and RBC is without nucleus, no nucleus in the case of RBC, you know it. It's a biconcave shape is a side view, and spherical is a front view, that also you know it. It has removed nucleus to accommodate more and more amount of hemoglobin, and that condition is called maturation of RBC, and which require which vitamin? Vitamin B12, which is called cyanocobalamin. Okay, that is regarding red blood corpuscles or red blood cells. Next comes the WBC, white blood corpuscles, also called white blood cells. They are divided into 2 types, friends. One is called agranulocytes, and the second is called granulocytes. And whichever has granules in cytoplasm is called granulocytes, and which don't have a granules is called agranulocytes. If I ask you regarding granulocytes, you can tell following things like a neutrophil, basophil, eosinophil. Agree with me? Yes. And if I ask granulocytes like a monocytes or lymphocytes. Agree with me? Okay. So come back here once again. Neutrophil. Among these, what is the way of remembering them? We can remember like this: never let monkey eat banana. Never let monkey eat banana, where never is a neutrophil, let is a lymphocyte, M is a monocyte, E is a eosinophils, B is a basophils. Means highest will be whom? The highest will be neutrophil. and least will be basophil. Hope the matter very clear for you. Yes, that was regarding the two things called as increase. Highest is the neutrophil. The neutrophil number goes on decreasing, preferably in the case of the leukemia condition. And it's a phagocytic in nature. Which one? Phagocytic in nature. Neutrophil. Monocyte is also phagocytic in nature. Monocyte later becomes what? Macrophage. So macrophage is a modified monocyte, means monocytes, the monocytes moving in the blood, they'll come out of the blood by a process called diapedesis. Diapedesis, by the movement called amoeboid movement. By amoeboid movement, diapedesis, and then this monocytes which is present in the blood will come out and becomes macrophages, where in a connective tissues. Okay, so monocytes are phagocytic in nature, I told you. Neutrophils are phagocytic in nature. Monocytes, then comes basophils. Basophils are responsible to produce chemicals like, tell me, yes, histamines, serotonin, vasodilator, histamine, vasodilator, responsible for allergy, vasoconstrictorities, which one? Serotonin, responsible for allergy also, and it also forms very important. What is that? You tell me. Heparin. Heparin is a natural anticoagulant. That is the reason in the blood vessels the blood remains fluid, do not get clotted because of the heparin. These three chemicals are produced by basophils. Which of the following is not produced by basophils can be asked. You should remember. And the next one, you should remember that basophils are also responsible for inflammatory response. Inflammation. Very easy. Why? Inflammation is because of these chemicals, histamines and serotonins. Yes, the eosinophils are responsible for allergic condition. That is the reason when a number of eosinophils goes on increasing, person becomes more and more allergic. Clear? So this was regarding the granulocytes and agranulocytes. Lymphocytes are two types, T and B lymphocytes, matured in thymus, matured in bone marrow, and T lymphocytes responsible for CMI, cell-mediated immunity, and B lymphocytes will produce antibody responsible for HMI, antibody mediated immunity, also called as humoral mediated immunity. Hope you understood regarding granulocytes and agranulocytes. Please go through once again. Everything was from textbook only few points were told extra. Moving to the one more thing called as thrombocytes, friends. Thrombocytes, which is also called platelets. Platelets are thrombocytes, and thrombocytes number will be 1.5 lakhs to 3.5 lakhs, and its number decreases during the condition called as dengue, which is called as thrombocytopenia. Thrombocytopenia occurs during what? Dengue condition. Listen, students, thrombocytes are not cells. They are not cells, they are fragments. In the bone marrow, there's one big cell called as megakaryocytes, which has a very big nucleus. So the megakaryocytes, this gets broken and forms lets. Which lets? Platelets. So platelets are fragments of cell. That is the reason they do not have any nucleus. And they're responsible for what process? Clotting of the blood. So that means blood clotting gets decreased during the time of what? Dengue. And you know that clotting factors, if it is less, it can lead to hemophilia also. I am moving to next aspect where students are having little confusion sometimes. That is regarding ABO blood group. I'll make one statement. This statement you have to remember. Recipient's blood should not, recipient's blood should not have any antibody. Recipient's blood should not have any antibody against donor's antigen. This is the principle regarding the blood donation. Recipient blood should not have any antibody against donor's antigen. Let me take one example for you. See here. Person A. Person is the person A, okay? The person A. The person A has blood group called as A. Blood group A. So blood group A is a person A's blood group. Person B has a blood group called as B blood group. Is the matter clear? So person A and person B, two people are there. So in the person A, the person A's RBC, the person A's RBC has an antigen, which is a sugars, chain of sugars, and this antigen is called as what antigen? A antigen. Okay, and person B's RBC has a which antigen, you tell me? It's a B antigen. So B antigen. Agree with me? So person A has a A antigen, person B has a B antigen. See, but person A's plasma has B antibody. And person B's blood group plasma has A antibody. A person who is having blood group B cannot form B antibody. He will form A antibody. A person who is having A antigen will form B antibody. Ulta means antibody will be always against antigen. That you remember that. So now let us see the condition. Let us think that person A is a donor. He is giving blood to the person B. So what is the principle? Recipient's blood means person B. Recipient's blood, person B is a recipient, right? Recipient blood should not have any antibody. Is he having any antibody? Yes, he has an antibody called as antibody A. Against donor's antigen. Which antigen is present here? Antigen A. See here. Antigen A here. Antibody A here. That means it is against this antigen. Against. That means this antibody will react with this antigen. The coagulation, a person can have difficulty. That means a person A cannot give blood to person B because recipient called as person B has a antibody which they can react with the A antigen of the person A. So this I want you to take down. See, formula: recipient's blood should not have any antibody against donor's antigen. So with this, I want to ask one thing to you. Tell me now, who is a universal donor? Donor who is universal is the, tell me, O blood group. Universal recipient, tell me. Yes, it is a AB blood group, we tell. But little in detail if you go, O negative is a universal donor. AB positive is a universal recipient. This also you should remember. I written here once again, AB positive and O negative. Hope the matter is very clear for you. Why he is a universal donor? You tell me. Because he don't have any what? Any antigen. Clear? He don't have any what? Antigen. But what about here? He has all antigen. He has all antigen. Since he has all antigen, no antibody. Is the matter clear? He don't have any antigen. He don't have any antibody. See, recipient he is. Recipient blood should not have any antibody. So he don't have any antibody. So he is a universal recipient. Please remember that. Moving to the next aspect called as RH blood grouping. See here, RH grouping. So the RBC has a antigen for A or B, you know it. But in addition to that, these antigens, it can have additional antigens. These antigens are called as Rh antigens. Rh antigen on the RBC. If a Rh antigen present on the RBC, then he will be called as Rh positive. In the world, most people are Rh positive. Reason, it's a dominant character. It's a dominant character. Clear? And what are the two traits in the case of this character called as Rh positive, Rh negative? Okay. Let us go to one condition here regarding Rh blood grouping, that is called as erythroblastus fetalis. Mother is Rh negative. Fetus or a baby, I can write baby is Rh positive. Baby is Rh positive, mother is Rh negative. You tell me, mother is Rh negative, but baby is Rh positive. Then how he become Rh positive? Because his father was Rh positive. That means he is a heterozygous, right? He is a heterozygous having minus and plus, but still he is expressing the character called as Rh positive. Reason, Rh group is a dominant character. See here, what happens? See the conditions carefully here. What happens is, when a parturition occurs, friends, when a parturition occurs means when a fetus comes out, during parturition, mothers and babies' blood can mix. Mothers and babies' blood can mix. When a mother's and baby's blood mixes, what happens is mother's body forms antibody. Mother's body forms antibody against fetus RBC, because RBC has that Rh antigen. Mother's body has formed antibody against fetus RBC. Which antibody you know? IgG. IgG is antibody. So mother's body in a blood, the IgG antibody is circulating, but baby is already got delivered, no problem. But what happens? Just see now here. In the second pregnancy, what can occur? I'll tell you now. This is the placenta, right? Placenta. And this is the condition where the baby is present here now, connected by umbilical cord. See, here is IgG now. IgG. Okay, what happens is, this IgG, which is against, and fetus has what? Fetus has RBC. Okay, so I'm telling this condition in where? In a second pregnancy. In second pregnancy, what happens is, the IgG of the mother who is produced against the RBC will attack the RBC. As it attacks the RBC gets ruptured. Now as the RBC gets ruptured, the condition will be called as, tell me, yes, erythroblastosis fetalis. Baby can die. And baby initially suffers from a condition called as jaundice, because of the RBC is getting damaged. Jaundice, the baby can get jaundice and baby can die because of the rupturing of the RBC, who is attacking an antibody IgG. So this IgG antibody is called as anti-Rh, means against, it's called as Rh antibody. Rh antibody, which one? This this IgG is against RBC of the fetus. So how to save? You can save the baby like this. How? You, after delivery of the baby in the first pregnancy, the mother has to be given with an injection, where the injection can neutralize this IgG, and that injections will be called as anti-Rh antibody. That means it is an antibody against a antibody. See, interesting things, right? It is an antibody against a antibody. So that is regarding the RH incompatibility. Mother is RH, tell me what, negative, and baby is RH positive. In this condition, there's a chance of the RH incompatibility. With that, I have finished regarding RH incompatibility. I hope that you have understood that. And blood clotting I will not be discussing in detail, because since it's a very easy one, and you should know that it's because of the fibrinogens, prothrombin, calcium is required for that, vitamin K is required for blood clotting. All this you should remember. And once again, vitamin K is required, prothrombin is required, thrombin is required, fibrinogen is required, and clotting factors are required. All is regarding blood clotting. I'll be moving to the next aspect, students. It's regarding circulation. All of you see here. This is the heart of the fish. Fish heart it is. Fish heart is a two-chambered heart. It's a two-chambered heart. It's a fish heart, two-chambered heart. In a two-chambered heart of the fish, it's a atria and it's a ventricle. Atria and ventricle. Hope the matter is clear. And this here is a area where blood can come down. Remember, this atria is completely filled with the which blood? The atria is completely filled with the deoxy blood. Clear? Deoxy blood it is. Ventricle is also filled with which blood? Deoxy blood. That means the heart has only deoxy blood. That is the reason fish heart is called as venous heart. Is the matter clear? Fish heart is called venous heart, reason it contains only deoxy blood. Then what is the pathway? Just see here. Deoxy blood from the ventricle pumped through the artery. And artery carries which blood, you tell me? Deoxy blood. And this will be cleaned because they don't have a lungs here. So they will be cleaned by a part called as gills. So gills will make a blood oxygenated. That is the reason I made this part red colors here. That means this contains oxy blood. And that oxy blood will be given to tissues. And once again it becomes what blood? Deoxy blood. Is the matter clear? So deoxy blood given to gills, and gills will make it oxy blood and given to tissue. Tissue once again which will add carbon dioxide and becomes deoxy blood. That means this circulation, how many times the blood comes to heart? Only once. So it's called single circulation. Clear? Since there is no lungs, only gills are involved, we tell this fish heart as a branchial heart. Clear, friends? This is regarding the fish. Hope you have understood regarding this. You can take a snapshot of it. Please remember that. And I'm moving on to the next type of heart here. This is the right atria. It's a left atria and it's a ventricle. That means it's a how many chambered? 3 chambered. So if it is a 3 chambered heart, tell me it is present in the case of which case? It is in the case of amphibia. Or maybe in the case of reptilia. Except whom? Crocodiles. Okay. So in this case, the left atria which contains oxy blood brought by the vein, and the right side has deoxy blood brought by the what? Once again vein, vena cava. So vein is bringing the blood to the heart, but here is a pathway. In this pathway, when it comes, the deoxy blood gets mixed with the oxy blood. Since deoxy and oxy bloods are mixing here, the blood whatever pumped will be mixed blood. That kind of circulation is called as incomplete double circulation. Hope you understood regarding incomplete double circulation, where blood gets mixed in the case of ventricles. Now we'll study in detail regarding the double circulation with the help of this diagram. Okay, see here, it's a heart. I'll take it from here now, just see here. And it's in this heart you will find here, this is the aorta. See, aorta is connected to where? Aorta to connect to left ventricle. That means it's carrying what? This is carrying which blood, you tell me? Carrying oxy blood. And the another part what you see here, the pulmonary artery. And pulmonary artery is carrying deoxy blood. Clear? And aorta goes to the different part of the body, except lungs. Pulmonary artery goes to lungs. Pulmonary word only you can tell. Pulmonary means lungs. So the matter clear for you now. So after that, these two are veins which carry oxygen blood to the left atria, sorry. This is the vena cava, and vena cava carries carbon dioxide rich blood to the right atria. These are very basic things you're studying from since your high school later on. Now, we will discuss regarding the double circulation. What is the meaning of double circulation? Quickly we'll discuss that. For that, let me take the diagram for that, double circulation diagram. Yes. See here, friends. Double circulation. For studying double circulation, every double circulation, every circulation starts with the atria and starts with the ventricle, ends with the atria. If I take this here, see here, starts the left ventricle, goes to aorta, comes to tissue, goes to vena cava, come back to right atria. That means the circulation from where to where? See here now, if I take the circulation, it is from the left ventricle to aorta, aorta to tissues, tissues to vena cava to the right atria. This will be called as systemic circulation. Left ventricle to right atria is called systemic circulation. But if I come back once again here, see here, right ventricle to pulmonary artery, pulmonary artery to lungs, lungs to pulmonary vein to left atria. That is called as what circulation? Pulmonary circulation. How? Tell me how. Yes, it is like this. It is the right ventricle to pulmonary artery to lungs, lungs to pulmonary vein to left atria. So right ventricle to left atria is called pulmonary circulation. So you find these two circulation which do not get mixed up. So this kind of circulation is called as what? Complete or a double circulation. And do you feel in each double circulation oxy and deoxy bloods are there? Yes, it is there. But you should remember, systemic means supplying blood to the part other than the lungs, but pulmonary means supplying blood to the lungs. Please remember that. Double circulation is over. The double circulation is found in the case of whom? Human being, means in the form of the mammals, as well as it is found in the case of the, tell me, yes, found in the case of the crocodiles. And regarding the heart structure, I will not discuss much about that, friends. Heart structure, you know that regarding heart structure more. Quickly, we will go for some of the aspects. Fast, we'll finish that. Yeah. Students, if I take this picture, some of the questions I want to ask you, see, tell me here, in a heart, if I take, this is the left side, it's the right side. That confusion you should not have, okay? And in this, here there is one valves, right? These valves are called as what valve? Bicuspid valve. And this side is called as tricuspid valve. You may ask how to remember. Sometimes we get confused. See, right. See, right. So tricuspid valve is found towards what side? Right side. Bicuspid valve is also called mitral valve. Mitral valve. That you should remember. These valves are very important. And why I'm telling is because the blood which is coming down here through the bicuspid valve is controlled by the bicuspid valve. We understood. In addition to that, there is a presence of a papillary muscles here, papillary muscles, and these papillary muscles will produce a fibers which is made up of collagen, which is called as heart strings, also called as chordae tendineae. Please remember, chordae tendineae is present in ventricles or atria. Yes, it is present in ventricles. Hope you understood. But when you come to here, I'm drawing papillary muscles and I'm drawing chordae tendineae 1, 2, 3. Reason? It's a tricuspid valve. And chordae tendineae here also it's present in where? Ventricles. All of you see carefully here. Why chordae tendineae present? When a blood comes from atria to ventricle, then ventricle starts contracting. When a ventricles are contracting, students, a pressure will be built on the valves. These valves should not open and blood should not go to the atria. So blood should not go to atria during ventricular contraction. That is controlled by chordae tendineae. Please remember that. So chordae tendineae will prevent backflow of the blood from the ventricle to atria. Hope you understood regarding chordae tendineae. After this aspect, I will be discussing regarding some conduction system present in the heart. Conduction system present in the heart is because of nodal tissues. You tell me, nodal tissues, are they neurons? No, they are muscles. Which muscles? Cardiac muscles. They are specialized cardiac muscle. Which one? Nodal tissues. The nodal tissues are this one. I'll carefully listen to the nodal tissues now. The nodal tissues are 1, 2, and 3, hope the matter clear. Let me once again tell that this nodal tissue is called a SAN, cyanoatrial node, and this will form the action potential around 72 times average. I have taken 72 times per minute, so it's called as what maker? Pacemaker. Okay, so who is a pacemaker? Tell me. It's a cyanoatrial node. Listen, what the upper corner has? SAN. SAN forms action potential, and that action potential will propagate through the 3 internodal fibers into AVN. Atrioventricular node is a AVN, which is called pace setter. Pace setter and pacemaker is a SAN. There are 2 nodal tissues over there, SAN and AVN. Cyanoatrial node, atrioventricular node. This atrioventricular node will propagate the waves to the next portion called as bundle of His. Bundle of His. And bundle of His will divide into left and right bundle. It divides into left and right bundle, and left and right bundle will divide and ultimately ends with the fibers called as, tell me, yes, Purkinje fibers. Why I have given this is, this can come for writing sequence here. Cyanoatrial node, internodal fibers, atrioventricular node, bundle of His, left and right bundle and Purkinje fiber. Clear? So this is regarding conduction of heart. Sinoatrial node is a pacemaker, and a pacemaker, when it's not working in our body, we can go for artificial pacemakers which is working from battery, and it has to be placed to the which region? Yes, right upper corner of right atria. We are moving on, students. This was regarding nodal tissues, and quickly going for the what is that? Cardiac cycle. Cardiac cycle. The cardiac cycle, which will work for 0.8 seconds, which works for 0.8 seconds, the cardiac cycle. And I'll write here, sorry, 0.8 seconds, the cardiac cycle. And the cardiac cycle has the following phases. One is called joint diastole. Agree? This after joint diastole, the next will be called as, tell me what? Yes, it's called atrial systole. The third one will be called as atrial systole over joint diastole, followed by atrial systole. Next one will be called as ventricular systole. Ventricular systole. The next aspect will be called as, tell me what? Joint diastole. During the joint diastole in the heart, all chambers will be relaxed. All chambers will be relaxed. Blood comes from the vena cava to the right side and from pulmonary vein to the left side. So all are what? Relaxed. And blood will flow passively to the ventricles also. That means ventricles are almost 70% filled by the joint diastole condition. Relaxed condition it is. No one is contracting. That is called joint diastole. But as the blood starts flowing to the ventricle, then after the joint diastole, what happens? Sinoatrial node, SAN, will produce action potential. Since it produces action potential, the atria starts contracting. When an atria is contracting, students, when an atria is contracting, I can write here, that means if I take it like this, atria is contracting. When an atria is contracting, what happens? The blood will flow, blood will rush into where? The blood will rush into ventricles. And that is called as atrial systole. Blood will rush into ventricles. The speed gets 30% fast when the blood flows into the, which one? Ventricles. After that, what happens? Now, when the blood has reached the ventricle, what happens? Here, if I take it like this, ventricles are relaxed. Ventricles are relaxed, but atria starts atria is relaxed, but ventricle starts contracting. This contraction of the ventricle is called ventricular systole. Ventricular systole, where what starts contracting? Ventricle starts contracting. When ventricle starts contracting, blood goes to where? Blood goes to respective arteries, like pulmonary artery and what? Pulmonary artery and aorta. Is the matter very clear for you? And after ventricular systole, then comes once again ventricular diastole. Diastole means relax. Once again ventricle, I can write like this, friends. Once again, tell me what? The ventricle is getting relaxed. Let me quickly. And pulmonary vein into the atria to ventricle, all are relaxed. Joint diastole. Why joint? Atria and ventricle both are relaxed. Atrial systole, why? Because here atria starts contracting because of SAN, sinoatrial nodes propagation. So atria is contracting. Why ventricle systole? Atria is relaxing, but ventricle is contracting. It's called ventricular systole. Clear? After ventricle systole, when ventricle is relaxing, it's called ventricular diastole. Hope the matter very clear for you. Just to see one aspect here. When the valve called as tri and bicuspid, when a tri and bicuspid valves are what? Close. When a valves called tricuspid and bicuspid valves are closed, that will create a sound called as what? Lub. And when does it occurs? When does this gets closed? It occurs when a ventricle is contracting. When a ventricle contracts, sound comes lub. Yes. Then the valve which is covering the pulmonary artery and aorta called a semilunar valve. Semilunar valve. When a semilunar valve gets closed, that creates a sound called as dub. And dub is the second heart sound. This occurs when ventricle is undergoing relaxation. Clear? When a ventricle relaxes, it is a sound is dub, and a ventricle contracts, sound is lub. Clear? All of you see, that means you tell me lub sound occurs when then? When a ventricular systole occurs, sound will be what? Lub. And a ventricular diastole occurs, sound will be dub. Hope the matter clear for you regarding lub and dub. Lub is because of the tricuspid and bicuspid valve getting closed. Dub is because of the semilunar valve getting closed. After this aspect, I'll take a small thing here and heart rate. Several times I paid question. What is heart rate? How many times heart beats per minute? It is 72 times, you know it. Heart rate. What stroke volume? Amount of the blood pumped by each ventricle is called stroke volume. See, each ventricle means from here how much? 70 ml. From here how much? 70 ml. Clear? So 70 ml is given per minute or per heartbeat. See here. So 70 ml is going to be the stroke volume. 70 ml plus 72, when you do it, it comes around 5.4 liters. Is the matter clear? And 5.4 liters is what? Tell me, cardiac output. And cardiac output can increase when you are going for a race, or it can decrease when you are under the anxiety condition. So this was regarding cardiac output. And I am moving to the next aspect, which is called as, tell me what? It's called as ECG. See here, electrocardiograph. In electrocardiograph, the graph will be like this. Electrocardiograph is a machine. Electrocardiogram is an output, printout. Remember, graph is not an output. Graph is a machine. In electrocardiograph, if I take it, students, there are waves like this. First the P wave, then the QRS, then the T's. So P, Q, R, S, T. P, Q, R, S, T. Clear? In x-axis we are taking time. In the y-axis we are taking voltage in the millivolt. Clear? Yes. What is P here? P is a atrial depolarization. Atrial depolarization means during this condition, SAN will be working, sinoatrial node will be working, and this will be leading to systole condition. Systole of the atria. That means during the atrial systole, wave will be P wave. Hope the matter is clear. What is QRS? QRS is a complex. QRX complex is regarding ventricle. It's a ventricle what? It's a ventricle depolarization. That means ventricle is getting contracted. So ventricular getting contracted preferably by Purkinje fibers is because of it is called as QRS. What is T then? T is the ventricle diastole. The ventricle diastole is also called as ventricle repolarization. Ventricle repolarization. Hope the matter is very clear. So atrial depolarization, ventricle depolarization, ventricular repolarization. Tell me which is not given here. Yes, it's a atrial repolarization is not given. Reason? Because the atrial repolarization occurs when ventricular depolarization occurs. Since ventricular depolarization is more and more intense, atrial repolarization gets masked. So we are unable to show the ventricular repolarization in the ECG graph. In a 2019, a question had come regarding ECG, little different way. See, I'm drawing one ECG for you. See here, time here, millivolt here. If a ECG comes like this, see here, P wave, QRS wave, then supposed to be which wave, you tell me? Supposed to be, tell me, T wave. But if a T wave comes like this, if a T wave comes like this, it's a P wave, QRS, and a T wave comes like this, this is called as this is a condition where we tell the person is having ischemia. What friends? Ischemia. What's ischemia? Where blood is not properly flowing. Reason? Maybe blockage. Reason for the blockage? Maybe atherosclerosis or maybe a myocardial infarction. That means this condition called as ST elevation. ST elevation or ST depression, sorry. When a ST depression occurs, the ST depression is reason is ischemia or blockage or myocardial infarction. That means when a patient goes to doctor, he finds the ECG like this, he tells that, oh, there is a chance of blockage somewhere. We may have to take care by taking medicine. If things become still and still worse and worse, they have to go for surgery or inserting stents. Clear? So this is regarding abnormal ECG regarding ischemia, blockage in the which one? Blockage in where? Blockage in the coronary artery. Hope the matter is clear regarding the electrocardiograph. And I am moving on to the next aspect, students, double circulation. You may have already you have explained, but I am explaining it in a different way. Just see here. Hope it is very clear for you. Just see here. See, this is the part called as right ventricle. It's a right, right atria, and it's a left ventricle, and it's a right ventricle. Clear? So blood is taken by the systemic artery. Systemic artery means into the what? Head. Into the head. That means what is this artery name? Carotid artery. Clear? And it brings back to the right atria. That means it has to be vein. Which one? It's called as vena cava. Which vena cava? It is superior vena cava. Written as superior vena cava. That was regarding head over carotid artery and brings back by superior vena cava. Coming to the lungs here. From left ventricle, the blood is taken by pulmonary artery into the lungs, coming back to the heart by pulmonary vein. That you have studied already. But come to here, what is that? From a left ventricle, the blood comes down. Blood comes down with the help of what? Systemic artery. Systemic artery. As it comes down, the blood will be pumped into the liver. The blood will be pumped into liver by whom? By the hepatic artery. By the hepatic artery. And after the blood, from the liver, blood will be going back to the vena cava. It's a vena cava, I already told you, with the hepatic vein. Is the matter clear, friends? Hepatic artery brings and a hepatic vein takes the blood from the liver. Clear? Now see the next one. This is small intestine. Small intestine gets the blood with the help of artery. We tell this artery as a mesenteric artery. Mesenteric artery. But Takes from whom? No connection. There is no direct connection from small intestine to into the vena cava. Why? Any food which is absorbed by small intestine has to go first to the liver, then to the vena cava. So there is some connection between small intestine and the liver. This portion, which is called as hepatoportal vein. Clear? And this hepatoportal vein, since it is there, which is connecting small intestine and liver, we tell it as hepatoportal system. I'll repeat once again. Is it a hepatoportal artery or hepatoportal vein? It's a hepatoportal vein connecting small intestine to liver. Hope the matter clear for you. I'll ask one more thing to you. See here, down, I'll write here. If this is the kidney, this is a kidney, and kidney receives the blood and it gives to the vena cava. Clear? So that connection is there. And who is giving blood to the kidney? Tell me. Yes, it's a renal artery. But who is giving to go into the liver only first? Is the matter clear? So you can just note down this very important one. I want to ask one thing to you, students. In the kidney, this is a kidney, right? In kidney, what happens is, in kidney, the ammonia which is released from the deamination reacts with the carbon dioxide. Ammonia reacts with the carbon dioxide and forms a product called as urea. Clear? This is called as urea cycle, which is occurring. Sorry, I'm very sorry. I'm discussing not this one. I'm telling this reaction called as reaction of ammonia and what? Carbon dioxide occurs in liver. Once again, ammonia reacts to the carbon dioxide to form urea. Urea occurs in liver. That means now liver has urea. This urea present in the liver has to come to hepatic vein. From hepatic vein it has to go to, tell me what? Heart. Then finally it has to come down into kidney. That means you tell me, that means when you come back to kidney, if I compare hepatic vein and renal artery, who will have more urea? It's a hepatic vein. Hepatic vein will have more urea because it is produced by liver. Please remember, who is producing urea? It's the liver. By what cycle? Urea cycle. Who is excreting it? Kidney. Urea cycle, which is also called as ornithine cycle. Ornithine cycle. And in ornithine cycle, ammonia react with carbon dioxide to form urea. Hope the matter is very clear for you. Is urea is produced by the kidney? No, urea is not produced by kidney. Urea is produced by, tell me, liver. Hope the matter is understood. I want you to just to see one picture quickly here. See here. Here, lumen area. Lumen of the vein is large. Lumen of the artery is less. That is the reason in artery, blood pressure, BP, blood pressure will be more in artery. Blood pressure will be less in vein. One point. You understood, right? Second point, in the case of artery, blood will move spurty way. Spurty means, let's say, push for the blood. Like this, jerk. So the blood flows spurty in the case of artery with the high pressure. But in the case of vein, the blood flow will be even, means sluggish. Hope the matter is clear. Blood flow is sluggish in the case of vein and it's spurty in the case of artery, and pressure will be more in the case of artery, pressure will be less in the case of vein. You just tell me, we are injecting blood to the, we are giving injection to the artery or vein? Yes, it is to the vein. Reason, one is pressure is less, second, it is superficial. Artery are deeply present. One more point, veins are having valves, artery don't have any valves. Lumen is large in the case of vein, lumen is less in the case of artery. and this is a capillary, students. And capillaries will always have, tell me what? Capillaries will always have one cell thickness. One cell thickness in the case of capillaries. Hope the matter is very clear. This is a appeared question. They had erased all this. They had asked question. Please remember that. They can even ask the pulmonary partial pressures here. You can mix it and ask also. We are moving on for the regulation of the cardiac function. Quickly see here. It's a brain. Which part of brain controls the cardiac function? It's a medulla. Medulla oblongata controls cardiac function. How? See here. It's a sinoatrial node, a nodal tissue which is called pacemaker. Whenever entry of the blood into the right atria, whenever the blood entry into right atria becomes less means blood pressure has become less. When blood pressure has become less, it is a function of sinoatrial node to increase the pressure. How? See here. Whenever the blood pressure is less, when a BP becomes less, blood flow to the vena cava becomes less. When blood flow to the vena cava becomes less, then sinoatrial node will get a signal from where? Sympathetic nerves. The sympathetic nerves will send a signal to the sinoatrial node, and because of that, sympathetic nerves are going to increase the heart rate. So heart rate is increased by sympathetic nerves because they act on whom? Sinoatrial node. Whenever BP becomes more, then you have to decrease the blood pressure to a meter called acetylcholine, and this will decrease the heart rate. Hope the matter clear. So the vagus nerve releasing acetylcholine by parasympathetic system will decrease the heart rate. Sympathetic system will increase the heart rate. Please remember that aspect. And one more thing you should remember is acetylcholine will decrease the heart rate only in the case of the heart. Means acetylcholine generally stimulated its inhibitory neurotransmitter only in the case of heart. You already know that adrenaline can increase the heart rate, and thyroxine also increase the heart rate. So we are coming to the almost end part of this chapter by discussing disorders. Okay, see here. A person having the blood pressure, which is measured by an instrument called as the sphygmomanometer, having 120 by 80, if it is there, it's a normal blood pressure, normal BP. Okay, but if it becomes the blood pressure 140 by 90, it's called as hypertension, or above than this, it's called hypertension. Hope the matter clear. So 140 by 90 is hypertension, 120 by 80 is the normal blood pressure. And one more thing you should remember, and a normal blood pressure and 140 and 90, if it is more, the other parts like the liver or the brain or kidney will be affected. Hope the matter clear. In this 120 is called systolic BP and 80 is called diastolic BP. Clear? And between 120 and 80, whatever the gap will be called pulse pressure. Clear? Yes. That was hypertension. See here now. What happens? A person is suffering from coronary artery disease, CAD, maybe like atherosclerosis, or maybe like myocardial infarction, MI. And when he is suffering from coronary artery disease, reason the lumen of the coronary artery has become narrow. Then later he will someday get chest pain. And as chest pain, what he is getting is called angina. The matter clear? And angina in which region? Angina in the pectoral region. Angina what region? Pectoral region. So it's called angina pectoris. It is a kind of warning signal. Sometimes people will be confused that it is a gastric. It may not be gastric. It will be chance regarding the problem regarding the heart. Why the angina? no oxygen. The oxygen for the tissues, cardiac muscles becomes less. After angina, if they don't take care, one day they may be affected by a condition called heart attack. What's heart attack? Where some of the cardiac muscles are dead. Not all. Some cardiac muscles are dead, so the heart is not pumping blood properly. That is called heart attack. Heart attack will do. Can you once again rejuvenate the dead cell? No. Because of heart attack, there will be some compromise in the heart beating that will lead to heart failure. Means, what's heart failure? Heart is not doing its work properly because some cells are dead. It goes on continuing. A person can suffer from a condition and cardiac arrest is the condition where heart stops beating. Once again, you have to study in a sequence only. There's a blockage. The blockage leads to chest pain, and chest pain can lead to heart attack. Because of heart attack, person can have a heart failure. Heart failure can lead to cardiac arrest. With that, we have finished regarding this chapter, and I'm going to take some of the important aspects of the excretory product and elimination. See here. If I ask some of the questions to you students, you tell me, if I take ammonia, urea, uric acid, if I take, you tell me, toxicity, solubility, and mode. If I ask you, among this ammonia, urea, and uric acid, which is more toxic? Yes, ammonia is more toxic. And urea is moderate toxic. Uric acid is least toxic. Hope the matter is very clear. First word over. Solubility. Ammonia is highly soluble. Urea, moderate. Or I can tell readily soluble. Uric acid, least soluble. Please remember, what is the mode of excretion of the ammonia? It's in the case of ionic form. Ions. And what about urea? Urea is in the liquid form. What about uric acid? Paste, or it may be pellet. Right or wrong? And ammonia, fishes, bony fishes, and some amphibians. Urea, human being and amphibians. Uric acid, birds and reptiles. Clear? Students, I'm moving to the next aspect quickly here. The next aspect which I'm going to discuss will be regarding the structure of the kidney first. See here now. When I take kidney, the bean-shaped structure, here is the pelvis, renal pelvis. And renal pelvis will extend as a calyces, renal calyces. And upon the renal calyx, there is a pyramids, which is also called medullary pyramids. Clear? Medullary pyramids. And the space between the medullary pyramid, this is called as columns of Bertini. Clear? And this renal pelvis will extend as what? Ureter. Hope the matter clear regarding the structure of the kidney. And if I take this kidney here we find nephron. This is the glomerulus, Henle's loop, PCT, collecting duct. So that explanation I'll be giving now. See here now. If I take this structure, students, this is the afferent arteriole, this is the efferent arteriole, and here is the tuft of the capillary called as, tell me, glomerulus. And this glomerulus will be surrounded by whom? Bowman's capsule. And Bowman's capsule will extend as what, tell me? Extend as PCT. PCT will later down become what duct? Tell me, Henle's loop. This is a Henle's loop. And Henle's loop will later becomes what? Tell me, DCT. And DCT will extend as what duct? Collecting duct. Is the matter clear? And what is it? Tell me, what is this one? This is the glomerulus. This is the Bowman's capsule. And glomerulus plus Bowman's capsule is called as what? Malpighian body. Also called as renal corpuscle. This is a PCT, DCT, collecting duct. And this is the Henle's loop. And this is the descending limb, this is the ascending limb. Descending limb of Henle's loop, ascending limb of Henle's loop. Is the matter clear? Now all of you see here. There are two types of nephron. If I take this is the renal medulla, and this is the Bowman's capsule glomerulus, this is the PCT, this is the Henle's loop. And this kind of nephron is called as medullary nephron or juxtamedullary nephron, and their number will be less. But another type of nephron, if I draw one more here, this is the condition here, PCT, only small part of Henle's loop, and this is called a cortical nephron. And number of cortical nephron is 85%. Number of juxtamedullary nephron is 15%. Please remember these aspects now. With that, I am moving on, students. We have left very little time. I'll cover the very important aspects which you generally have doubt. See here. What happens? I'll take this picture only for you. Blood will flow with the high blood pressure through a afferent arteriole, AA. And blood will come to glomerulus, which creates a pressure. Because of pressure, a filtration takes place. And that filtration is called as ultrafiltration. Is the matter clear? And ultrafiltration takes place, blood has reached to where? The blood has reached to the where? Bowman's capsule. Is the matter clear? Just to see here once, to this diagram. Is an afferent arteriole. Through the afferent arteriole, blood is flowing with a great pressure. And with the great pressure, blood comes down. In the glomerulus region, a pressure has been created which leads to filtering of the blood. That filtering of the blood will filter almost everything except for blood cells and proteins. And that will be called as what? Ultrafiltration. The point 1, ultrafiltration. Then, listen carefully everyone. After ultrafiltration, whatever found in the filtrate is called glomerular filtrate. The whatever required present in the filtrate has to come back to the blood. And the process where it comes back to blood is called as reabsorption. Clear? And one more thing, whatever present in the blood, if not required, has to come back to filtrate. That is called secretion. Is the matter clear? So what is filtration? Glomerular filtration is ultrafiltration because it is occurring with a high pressure. And whatever moving from the filtrate to blood is the reabsorption. Blood to the filtrate is the secretion. Is the matter clear? So that is the reason when you see this picture is very easy. When this picture, wherever you find arrow marks above, the arrow marks to the above points, this all will be reabsorption. Please remember, if arrow marks are above, it's a reabsorption. Clear? And reabsorption occurs to blood. Clear? And wherever you see the arrow marks down here, these are all secretion. Is the matter clear? And secretion occurs from the blood into filtrate. And remaining everything is easy. What? PCT, what gets reabsorbed and what gets secreted? You can learn here. DCT, what gets reabsorbed and you can see here. Bicarbonate, water, sodium chloride, K plus gets reabsorbed in PCT. Sodium chloride, water, bicarbonate gets reabsorbed in DCT. And you should know one thing, whatever reabsorption occurring in a PCT is compulsory. Means it has to occur. And here, preferably it occurs by an active process. What process? Active. Means by spending energy. Active process preferably for the reabsorption of sodium and glucose. So glucose and sodium is reabsorbed by what process? Active process. In where? In PCT. And this reabsorption occurring in a PCT is compulsory, I told, right? So since it is compulsory, it's called as obligate. What's obligate? It has to occur in where? PCT. But when you see the DCT, the reabsorption occurring here is a passive way. There is no use of energy for anything. And this is a facultative. Facultative means conditional. It occurs only if it required. So once again, reabsorption PCT is obligate. It is facultative in DCT. Reabsorption is active of some other things in the case of which one? PCT, and it's passive in the case of DCT. Hope the matter clear. You can see that aspect in the textbook quickly here. See here, listen. See here. For example, substance. Is the matter clear? And regarding the PCT, what gets absorbed and secreted and everything you understood now. And I'm going to two important aspects of this chapter. With that, I'm almost ending the chapter. Just see here. That is, what is that? That is a counter current mechanism. Some student may have doubt regarding that. See carefully here. Students, this is the Bowman's capsule, and this is a PCT, and this is the Henle's loop. DCT. Hope the matter clear. And what has occurred? Tell me what here. Here is the glomerulus, afferent arteriole, efferent arteriole, and is a glomerulus. Ultrafiltration took place. Here filtrate has formed in PCT. Reabsorption occurs. Secretion occurs like this. Arrow marks. Reabsorption occurs like this. Secretion occurs like this. DCT. And it's a collecting duct. See here. This portion of the what? This portion of the Henle's loop will be surrounded by one more blood vessel, which I'm drawing here now. And this blood vessel, whichever I'm drawing now, will be called as vasa recta. This is a vasa recta. Recta means straight. Vasa means blood vessel. So this is the Henle's loop. This is a vasa recta. Listen carefully. And this part of Henle's loop is called as descending limb. Clear? This part of Henle's loop is called ascending limb. Why? Because filtrate will be flowing down here. Filtrate will be moving above here. This is called counter. Opposite. Similarly, in the vasa recta also, blood will be flowing down here. Blood will be flowing above here. That is also counter. Hope the matter very clear for you. So this means this is the descending limb and this is the ascending limb of vasa recta. Ascending limb of vasa recta, descending limb of Henle's loop. Ascending limb of Henle's loop, descending limb of vasa recta. Is the matter clear? Now see here what happens. From the descending limb of Henle's loop, water will come outside. H2O comes. That means aquaporins are found in descending limb of the Henle's loop. It comes out and this enters to where? Tell me. Enters to ascending limb of vasa recta. That means water will come from the descending limb of Henle's loop. Similarly, in the ascending limb of Henle's loop, water will not go outside. But who will go outside? Yes, it's a sodium chloride. NaCl. So sodium chloride, so right here now, NaCl will go from the ascending limb of what? Henle's loop, and that will be reabsorbed by, you tell me? Yes, descending limb of vasa recta. I hope the matter clear. That means descending limb means first is a descending limb is permeable to water and ascending limb is permeable to sodium chloride. Please remember that. Since, and not over, the sodium chloride is moving in where now? It's moving in the what? Descending limb of the vasa recta. It comes to here. Who? Sodium chloride. From the ascending limb of vasa recta, sodium chloride will come out. Not all. Little sodium will come out of the, tell me what? Ascending limb of vasa recta. Since sodium chloride is coming out of the vasa recta, this area called as medulla, here concentration of salt goes on increasing. One thing. Second thing, from the collecting duct, urea also will come outside. Since urea is coming outside, sodium chloride has come out. This area become highly concentrated. Because it's very highly concentrated, what happens? Lot of water will go out of the collecting duct. And since lot of water goes out of the collecting duct, this area get highly concentrated. I'll show you that picture here quickly. All of you see this. This is the PCT, right? This is a descending limb of vasa recta. Sorry, descending limb of Henle's lobe. Ascending limb of Henle's lobe. Here water comes out. Agree? And as the water comes out, you can see the values are increasing 300 to 1200. That means they are becoming concentrated. And as the sodium chloride is moving outside from the ascending limb of what? Henle's lobe, the values are decreasing, meaning they are getting diluted. Remember that. So, descending limb of vasa recta is permeable to water. Ascending limb is permeable to sodium chloride. And because of that, what happens? You tell me. And urea comes here, see, urea comes from the what duct? Collecting duct. This entire area become highly concentrated. That is the reason the osmolarity increases from 300 to 1200, which makes release of lot of water from the collecting duct. Is the matter very clear? Quickly to recap once again here, tell me, descending limb is permeable to water, ascending limb is permeable to some amount of the sodium chloride comes back to the what? Medulla by the ascending limb of vasa recta. Hope the matter is clear. Because of this mechanism is called as counter current mechanism. I am in the last two aspects of this chapter. Very important one. What is that? It's called as renin angiotensin aldosterone system. RAS it's called as. What does that? See here. Whenever blood flow into afferent arterioles become less, filtration can become less. When filtration can become less, the blood will have more and more impurity. More and more impurity in the blood can create problem. So we have to increase the filtration. That is the goal of the RAS. That means when a blood flow, if it is less, when a blood flow is less, what happens? See here. When a blood flow is less, a cells called as cells of juxtaglomerular apparatus. What is juxtaglomerular apparatus? Cells of afferent arteriole plus DCT. Very easy to remember. AA plus DCT is equal to JGA. Remember. So when a cells of juxtaglomerular apparatus called as juxtaglomerular cells, they secrete renin. Spelling you see only single N. This renin will convert angiotensinogen. Angiotensinogen means inactive, produced by liver. It converts angiotensinogen into angiotensin 1. It converts angiotensinogen into angiotensin 1. And angiotensin 1 becomes angiotensin 2. Good, have you understood? And angiotensin 2 will act as a vasoconstrictor. Act as a vasoconstrictor, so the blood pressure becomes more. Another way, angiotensin 2 can act on adrenal cortex, and it acts on adrenal cortex and produces, adrenal cortex forms hormone called aldosterone. And as aldosterone produced, it can make a reabsorption of sodium and water, and once again blood pressure increases. So it increases blood pressure in two ways. One is by aldosterone and one is by vasoconstriction. Who? Angiotensin 2. So RAS means renin, angiotensin, aldosterone system, which includes liver, kidney, JGA, and even the adrenal gland. Is the matter clear regarding RAS? Students, I am moving to the another aspect here. You tell me which is the antidiuretic hormone which is produced by hypothalamus, which helps in reabsorption of water. Where? In the DCT. The last aspect which I am going to discuss will be regarding the disorders. In the disorders, the very important one is uremia. What's uremia? Where urea concentration in blood will increase. Urea concentration in blood will increase, that is called uremia. And what is the remedy for that? Remedy is the dialysis. Hope the matter is clear. And dialysis, you should remember, dialysis is a condition where dialysis fluid, they may ask this, dialysis fluid contains all aspects of blood but no urea. This you can remember. In addition to that, one more disorder which is the called as renal calculi. And renal calculi is because of, tell me, oxalates of calcium. And it's also called kidney stone. And the last one is a glomerulonephritis. Glomerulonephritis is the inflammation of glomerulus. Students, quickly to ask something to you. See here, we discussed regarding RAS, right? RAS, where a vasoconstriction occurs because of angiotensin 2. Is anything which is vasodilator? Yes, it's ANF. What's ANF? Atrial natriuretic factor. It's a ANF, and ANF acts as what? Vasodilator. That means renin-angiotensin mechanism will increase the BP and ANF will decrease the BP. That means angiotensin and ANF are antagonistic, or renin and ANF also antagonistic. Hope the matter is clear. So to quickly revise regarding excretory chapter, see here. Here we discussed initially regarding the, tell me what, urea, uric acid and ammonia and their excretory products and toxicity, you should remember. Then regarding structure of the kidney, I did not, little bit only I could discuss that, where it's made up of a pair of kidney, pair of ureter and one urinary bladder, and you should remember that. Then we went on for discussing regarding the structure of the kidney, columns of Bertini, you should remember that. Then structure of the nephron we had discussed. Then we went for this structure called as Bowman's capsule and covered by the glomerulus called as Malpighian body, also called as renal corpuscle. Then went for this aspect called as filtration, ultrafiltration is occurring. Then reabsorption means arrow marks above. Secretion means arrow marks towards the PCT or DCT, you should remember. And what is the glomerular filtration rate amount? Yes, it is the 125 ml per minute glomerular filtration rate. And please remember all these aspects. Then we went for counter current mechanism for concentration of urine, and which limb is permeable to what, you should remember. This descending limb is permeable to water, ascending limb is permeable to sodium chloride. In the case of Henle's loop, that you should remember. Renin angiotensin aldosterone mechanism we had discussed, which increases the blood pressure. Atrial natriuretic factor, which will decrease the blood pressure, we had discussed. And ADH, a antidiuretic hormone, will prevent diuresis, means it makes the urine to get concentrated in the DCT as well as in the case of what? Collecting that. In addition, at the end we discussed again disorders. Clear? And these are the memory oriented aspects. I want you to properly go through the textbook and study. Students, we were able to, in a given time, we were able to complete 3 chapters. Most of the important things regarding 3 chapters we are able to complete it. I want you to study, revise the things properly once again, and any doubts regarding any things you can ask in the doubt portal, and keep repeating, keep revising, and I wish you all the best. Now go and have your lunch. Thank you. See you some other time.